So, afternoon everyone.
Good afternoon.
So before we head straight into my research, I'm going to tell you a problem, the problem that I'm researching. So the problem I take is about the plastic bag. Well, we have a very special case here, especially in Bandung, because plastic bags are usually refused by recycling companies because it has very low value. And, well, they're also misused very dangerously in Bandung because they're misused for food. Probably not just in Bandung, but all of Indonesia. Well, you can imagine how dangerous this is to human health. So, I came up with a solution from researchers that I heard about mixing it into asphalt. So that's why I came up with this kind of solution. Plastic asphalt. I'm PAKSI RAGANATA representing Indonesia from St. Mary I High School in Bandung. So this daily waste generation of plastic bags in Indonesia reaches an amount of nearly 1,800 cubic meters a day. So imagine this. It biodegrades in 500 years, and in the next 50 years, it's just 10% of its biodegrading period. It almost reaches an amount of, well, times 50 is 50 million. Sorry, it's not in there. And so, about the alternative solution, if we use this in Indonesia, Indonesia has one of the longest road span in the world, with its national road, not including provincial and local, already stretches nearly 38,000 kilometers. And also, if we use this as a solution, it has no impact on environment and human health, because rather, imagine this: you burn it, and the dioxide and chlorine will be released to the air, while if you put it within the asphalt, it becomes binded inside, and it'll never come out anymore except it's exposed to very high temperature. Also, it can be useful for modern-day civilization, whose infrastructure relies heavily on roadways. Well, the question is, first, will it work? Because from previous research, they were using polymers. I mean, the non-trash plastic bags. What I'm using here are trash. And also, what's the maximum proportion of plastic allowed for the optimum performance of the road? So also, what kind of road its performance qualifies for? We can say it can be useful for highways. It can be used for residential roads. So to find out about that, first I'll compare the performance of the plastic asphalt with normal asphalt. First, in asphalt phase, still those kind of oily substance, and second is asphalt mixture phase, where you mix it with the rocks. So to mix them, first I must cut the plastic in a very small size, maybe half centimeters. Then I mix it with the asphalt in a certain temperature, and also in certain duration, which is different from normal asphalt because you're mixing something else within it. Also, for the asphalt mixture Also, I pounded aggregates, the rocks, and asphalt in high temperature, 75 times both sides, until it makes these cylinder samples like this. So for the performance parameters I took, which are considered specifications for the asphalt phase, the oily phase, the first is ductility, which is the flexibility of the asphalt when it's exposed to load. So the second is the penetration rate. This is used to measure how strong the asphalt, as imagine a glue, can glue the rocks, the aggregates, on top of it. The third is softening point. This is to measure the quality of the asphalt when it's exposed to very high temperature. Also, and the fourth is loss of weight. This is used to measure the amount of light oil within the asphalt that preserves its quality. I took 5 samples which are 0% as control, 2, 4, 6, 8, 8% of plastic weight compared to asphalt weight. So, and for the asphalt mixture phase, I will take, well, we can say some kind of power test. The Marshall stability test. Because the asphalt will be pressed here, and once it breaks, it will mark its strength. These are the results. The first results of ductility. Well, we see here plastic asphalt. It becomes less elastic when it's heated within the asphalt. So you can say this asphalt is not very flexible. And for the penetration rate, we can see that the more plastic is put into the asphalt, it becomes lower. So you can say more plastic, the more weaker it is to glue your rocks. And for the softening point, we can see here that it shows a good increasement. The more plastic you put, the more resistant it is to temperature. And for the loss of weight test, we can see that actually, based on it doesn't. Actually, the plastic asphalt already loses most of its light oil when it is heated in its way, because it's different and it takes longer heating than normal asphalt, so it loses more. As for the stability test, we see that plastic asphalt is, well, weaker than normal asphalt when it's exposed to load. So, based on the results, I concluded that plastic asphalt may be a promising solution to tackle the plastic waste problem. However, maybe it can't be used on highways, but it may be used on residential roads, I presume. And the optimum proportion here is 4% for maximum performance. The advantage of using this compared to normal asphalt right now: first, it has increases in temperature resistance, but the disadvantage is that it has less flexibility and it can fracture more easily. So just say it's weaker. For future research, I suggest we find an easier way to mix the plastic within asphalt, because it takes very long time. And well, maybe we hope that maybe reducing the time will also reduce the amount of lost oil that is lost within the asphalt. Also, we should find a new substance to improve the flexibility of asphalt, because asphalt is a flexible pavement. Well, the movement of aggregates on top of it must return back whenever it's exposed to load. So whenever a vehicle passes by, it will move up, and it should be back in its way. So that's all from me. Thank you.